Welcome to my talk. My name is Gloria Dwomoh. I'm a computer systems engineer, and this is an introductory talk about cloud computing and Cloud Foundry. We'll start from the very, very basic, kind of like learning ABCD, and then go into the more complicated stuff in order to build up from the easy to the harder, and also create a good foundation so that things can be easier for you in the next talks. This talk came as an inspiration from an experience I had some years back in an interview. Before the interview, I asked the recruiter, do I need to prepare anything? I was told, no, you don't need to prepare anything. Then I went to the interview, and one thing I was asked is, what is cloud computing? What do you know about cloud computing? And then I was like, I've heard about it. In my mind, of course, I've heard about it, but I'm not really sure what to say. Let me say what I know. But then after that interview, I got a feedback, learn more about cloud computing. It is the future of infrastructure. And since then, is when I began searching about what cloud computing is and how can I make it easier for other people to understand, because I studied computer engineering. I had like a technical background, but still it was an abstract concept that was kind of hard for me to fully understand what it meant. So with that came this talk, and I hope that what you learned today gives you the good fundamental knowledge to make the other talks understandable for you and approachable. So let's start. Yep. Outside, I think it's from outside. It's from outside. Okay, so yeah, now hopefully you can continue for background music. So the first thing that I'll talk about is one of the most asked questions in interviews is explain X to someone. And that usually is to explain a very complicated concept to someone in order for them to see how well you are in breaking down various concepts. And in our talk, the X will be cloud. So I decided to consult the social media warriors to give me an explanation of what cloud means. And when I did that, I got various great responses. The first one that I got is this one here. As I can imagine, that is exactly what most of you first thought when you hear the word cloud. And there's a research that was done by Citrix in 2012. And there they say that first to mind, when asked about what cloud computing is, the majority thought that it was a cloud in the sky or something related to the weather. So it's actually real that a good amount of people still don't fully understand what cloud computing is, but there are people that do know, and that's a good thing. So that is why we'll begin with the very fundamental parts. But the social media warriors didn't stop there. They gave me a reality check by giving me this meme here. And it's like, okay, cloud computing is just someone else's computer. So that made me wonder, okay, it's not the skies, it's someone else's computer. And that can make someone a bit paranoid. It makes you wonder if someone else's computer could be your coworker's computer and they are spying on you, and then you have like a third-party person behind the scenes looking at what you are doing. But no, that is not what cloud computing is. And eventually the best response came through this meme here, which is like the closest, one of the best explanations that I've seen. Yeah. It's one of the best explanations that I've seen so far. Like, Daddy, what are cloud made of? Linux servers, mostly. Yes, that is actually true. So with that being said, let's take things a bit backwards. Let's do a history walkthrough with how cloud computing first came about. So we first had something called the monolith, which was like centralized computing, all the peripherals, and was controlled by one central computer, which did complex computations as well. And that paved the way for monolithic applications, which are applications that run as one unit. And that word comes from the word monolith, which is a Greek word that monos means alone, and then lithos means stone. So everything is like one unit, one unified stone. And after that, we had like, we needed a change because this made things to be costly because you needed to upgrade your systems each time. You needed like more bandwidth for users and other things, and it was hard to support a lot of users concurrently. So that paved the way to decentralized systems, distributed computing, which was a great advancement in technology, and it enabled organizations to be able to scale their projects by having no upfront hardware costs. And that is how cloud computing came about. And also that enabled organizations to leverage third-party infrastructure instead of having their own. So now we know what cloud computing is, we know what cloud is, but what is cloud computing? And here I say that cloud computing is the ability to deliver services over the internet. That is like the simplest way to put it. And as we go along, you'll be able to see more of what we mean by services. So I want us to see a bit about what is the cloud infrastructure architecture. The cloud architecture usually has like a front-end side, which is like the client infrastructure, and then it has like the back-end side, which is like the storage, the cloud runtime, and more things. So it's kind of like the way we have application sets today, that it has the front end and then the back end. And then we have something else which is called the cloud service models, which is what we have seen like X as a service. So people say like, let's say infrastructure as a service or platform as a service. They have different names for that. And that is any service that can be delivered to a vendor or an organization through the internet with the use of cloud computing. So let's see a few of the common ones that you might come across today in other talks, or you might have seen, or you will see in the future. One of them is infrastructure as a service, and you often see it as an abbreviation, the IaaS here that you see. And that is it's like the provisioning of fundamental tools, things like virtual machines or physical machines, resources in order to be able to run your application. And that is like platforms like the Google Cloud Platform or the Microsoft Azure that some people use to run, use in conjunction with Cloud Foundry. And infrastructure as a service, it provides, as I said, virtual machines and other components that are made available through virtualization. So then we have software as a service, and software as a service is any type of software that runs online in the internet. You can see it in the abbreviation of SaaS, and that is softwares like, let's say, Gmail, CMS, content management systems. And then we have something else like identity as a service, which is being able to have like a digital authentication system where each user is able to use a single password, for example, to sign in on all the systems of your organization. And the last example that we'll give, because there's much more than these four that I'll say here, but these are some basics that you see often that are good to know. The last one that I'll speak about is platform as a service. And I've put a star here, and we'll step a bit more into this because this is very related to Cloud Foundry. So what is platform as a service? So platform as a service is a model that offers runtime for applications and also the tools needed to deploy and develop your applications. And that is exactly what Cloud Foundry does. So knowing that, let's move on into what Cloud Foundry is, which hopefully a lot of you know already. So Cloud Foundry is an open source cloud application that helps you to deploy enterprise cloud applications. And Cloud Foundry makes things easier for you in relation to the traditional IT or the infrastructure as a service platforms. So what it does is that it makes you have to manage fewer things that you will have had if you didn't use Cloud Foundry. So with Cloud Foundry, you manage the application and the data, as you see in this diagram here. And then Cloud Foundry manages all of these other things in the infrastructure as a service, which we explained what it was previously. And here is some example of it, like Amazon Web Services, Whisper, OpenStack, and so on. And it does that, it helps us do that with the use of Bosch. And we have to see like what Bosch exactly does. Bosch unifies the release engineering, deployment, and lifecycle management. So that is how it's able to handle a lot of these things here we showed here. Cloud Foundry is able to handle a lot of these things we have showed here through the use of Bosch. And Bosch also makes it easy to roll back when you have like some issues with your updates or yeah, you have done something wrong. And also Bosch is commonly used by Cloud Foundry because Cloud Foundry needs various bunches of virtual machines in order to run. So Bosch is what is commonly used for that. And also, as you see here in the slides, it creates and deploys virtual machines. So these are a few of the benefits of using Cloud Foundry. One of the very important one is it helps with vertical and horizontal scaling, and a lot of platforms that have a lot of users need to continuously scale. And this is how a few of the ways that Cloud Foundry can help you. So how does Cloud Foundry help you focus on development while it handles all the other things for you behind the scenes, like the virtual machines, creating containers, and all those type of things? We'll see that through exploring what happens when we do CF push, which is pushing an application with the use of Cloud Foundry to the cloud. So first we have the Cloud Foundry controller, and what it does is help us find the needed build package. We'll see what it is next. The Cloud Foundry controller is like the brain of the process, and it manages the entire application lifecycle from the beginning to the very end. So after CF controller finds the needed build pack, what build pack does is it creates an application image. And in short, this is what build pack does. It helps us to identify the necessary dependencies to configure the app. So for example, if the app you're uploading is made on Ruby on Rails, build pack is able to identify that through a process here that build pack goes through. For example, it goes through first detecting if you actually need any build packs, and after that it supplies the dependencies you need. So for example, on the Ruby on Rails example that I gave, it will help you install the necessary like gems or any other things that you need to run your application. And once that is done, it provides that feedback to Cloud Foundry, indicating how it should execute your application. And then once build pack has created that image, Diego comes and takes that. That image is called Droplet, and it runs it in a container called Diego Cell. So now we are going to see what Diego is. And in short, Diego helps us manage application containers. So we'll look a bit of what Diego does. I'll explain like part of it because like Diego can be a full talk of its own. So what happens is that when we do the CF push, the cloud controller, which we said that is like the brain of the process that helps manage things, it passes the request to the BBS, which is the bulletin board system, and it's a central data store that allows us to store various information about our application. So what it does is that the bulletin board system stores the things that we have passed through in the request in the database, and then after that, it creates an auction via auctioneer, which then finds the right cell for us to run the application by consulting with rep here, which accepts the auction request. And then what that does is it executes what we have given to it through creating something that we call a garden container, which is what this thing here is. And by the creation of the garden container, it downloads like every information we have given in the droplet image that resulted from the staging process we did before, and it enables us to run the Cloud Foundry application that we have given to it. So the other things that it does here, we won't really dive into it because it's not very relevant to our talk right now, but you can read more about it through this link here that I've written as a source. So let's see a bit about the best practices when it comes to creating cloud native application. And by cloud native application, I mean applications that are designed to run on the cloud primarily. So there was the creation of something called 12-factor methodology in the initial stages of cloud computing, as people try to find like guidelines of like what is the best practices that we can follow to create cloud native applications. And that means applications that were primarily created to run in the cloud first. So the 12-factor methodology gives us like 12 different factors that an application have to have in order to be portable and resilient when deployed to the web. So I won't speak about all the 12. I'll focus on 2 of them right now, which are relevant to what we are speaking. One of them is dependencies. One of the things that it says is the application have to have dependencies, and that is something that Buildpack manages, which we spoke about before, that it finds the dependencies that our application need in order to run efficiently in the cloud. And another thing that we are going to see is processes. Your application has to be able to run on multiple servers, and for that to happen, you have to be able to use processes. And as we said before, the application needs to run in multiple servers. So that is one thing that we have to know about processes. And the other thing is that web applications are stateless. So every request to the web isn't saved. It's seen as a U request. So if we want to save the state that we are in right now, we have to use something that is called backend services, which is also called like storage. And so the thing is that we have spoken about the 12-factor, and one of the components in it is, as we said, processes, and databases are decoupled from stateless applications, which we said web application are. So the question that comes in mind is that Diego cells are great for running stateless applications, but where do we get like the app databases that we need in order to back the state, for example, that our application needs? And there is where the Open Service Broker API comes in. Developers can provision and bind particular services to an application. So, for example, in our talk here, we spoke about databases. If we needed databases, we can get that through the Open Service API and bind it to our applications. To see the other services that we can use aside of databases, we can do that by using the CF Marketplace command. When you do that, it will list the various services that you can use for your system, one of which is databases. And then, for example, if you want to create a database, we use the CF create service command to create the database, and then we have to bind it to our application. And we do that with the CF bind service. And once we do that, anytime we push the application, it will create the processes that we need, and it also attaches the services automatically if we have bound them previously to our application through the steps that I've explained before. Open Service Broker API has had some new updates a few months ago, and now, for example, it improves asynchronous operations, and it does a lot more other things. I've added like a last slide in this presentation that has resources that you can see more of the updates, and also you can dive deeper into Cloud Foundry and the concepts surrounding it. And with that said, my talk is coming to an end. I would like to thank Swarna and Denise, you. This is my first talk at Cloud Foundry Summit, and they really helped me prepare with the presentation and gave me moral support. So I would like to say a big thank you. And also, you can find my slides here. You can also find them on the schedule webpage, but if you want like an easier way to access, you can find it here. Oops, I hope those of you taking screenshots, let me wait a bit. I hope the screenshot, okay, everyone is done. And you can also find me around on the web. @Blossomica is my GitHub handle if you want to find me there. And if you go to linkedin.com and write/in Gloria Dwomoh, you can find my LinkedIn if you like to follow me or connect. And then here's my website if you like to check my website. And with that, I'm done. So I think I'll take one question. So does anyone here has any questions that they would like to ask? Okay. Okay. What? Can you speak a bit more loudly because I cannot?
I'm from IDC.
Ah, okay.
Corporation. My name is Ivana, and I'd like to ask you can maybe explain us, if you can, the business model behind Cloud Foundry.
When you say business model, what exactly?
Because you have a lot of providers, a lot of companies who are the part of Cloud Foundry. So if there is any business model, because they leverage on code, they leverage on the tool.
I can help with that. So I'm from the foundation, and probably that is not an relevant question for her. I mean, I can explain it to you in detail as well, but if anyone else also has a question, I can explain it to you. Does anyone else also want to hear the answer about the business model around Cloud Foundry? If not, I can just do it in okay.
Yes, so the business model we'll explain later. Anything related to this talk in specific?
I have a question.
Yeah, you can.
I know you gave me credit. I did not help you with anything. My question is, did you learn all of this by yourself?
Yes. I studied all of these things by myself. As I said, after that interview, I was told to learn about cloud computing. So then I started digging and digging and digging, and that's how I learned about Cloud Foundry. And I did some like online courses. There's one at EDX about Cloud Foundry for those of you who like to do courses. And there's like, they have the documentation and many other things, resources that you could use. So that is how I learned about it. So it's something you can learn by yourself, but it's always better if you can have someone to help you, because then you don't have to struggle as much. But hopefully with this talk, it does the same thing. It will help you not need to struggle that much with the other talks that are following this talk. So yeah, that's it for now.